screenshot this. Now let's answer the questions correctly now. Question number 1. They asked us to, that is BI. What we have solved is question 25A. Sorry, 25A. 25A. This is it. And the graph is well represented. This is exactly how you should attempt this question when you are in the WAEC hall answering your questions. The axis leveled correctly. If you don't put this axis, you lose marks. And then choose scale. Here, what I just did here is 1 cm to present 10 units on the horizontal axis. And here, I've chosen 2 cm to represent 50 units, meaning half of this is 25. This is 75. Do you get it? So, in that order. Now, they asked us question 25 BI. 25 what? BI. BI asks, use the graph, using the graph, calculate the maximum speed attained during, calculate the maximum speed attained during the motion. So the maximum speed attained during the motion is simply what? Look at it here. Look at it. 340. So we can say that V maximum is 340 meters per second. We have answered that part of the question. Now they ask us BII, average retardation as the body is being brought to rest. The average retardation as the body is being brought to rest is simply this particular triangle here. So we are free to say this is our S1, our S2, our S3, and then our S4. I will explain the meaning of this later. So the average retardation is simply this. As retardation simply means negative acceleration. So we have A is equal to V minus U all over T. In physics, when a body is starting from rest and is moving, U is 0. But when a body is trying to retard, to slow down and off the engine, we say that what? V is 0. Starting from rest, moving forward, U is 0. Coming down from where it has moved to a higher velocity to slow down, V is 0. So in this case, our V is 0 down here. This is retardation. C, D is your retardation. So our A is equal to what? Minus U all over T. In this case, our U, our initial velocity becomes what? 340. So we have our A as what? Minus 340 divided by time. The time here is simply what? 20 seconds. This is 10, 20. The time is what? 20 seconds. This will cancel, this will cancel. So you have your A is equal to what? Minus 34 all over 2. What do you have? Your answer is what? 15, 16, 17. 15, 16, 17. So your A is minus 17. Let me confirm that. That is 340 divided by 20. Yes, I was correct. So, but we can't put minus 17 there. No, that minus is simply telling us that this is retardation. So the ideal way of writing this is retardation A is given as what? 17 meters per second square. This is our retardation. You can quickly screenshot as I solve the next question. The next question is BII. Calculate the total distance traveled during the first 5 seconds. The total distance traveled during the first 5 seconds. Permit me to clean this so that we're solving everything here. That is, we are solving BII now. Total distance traveled during the first 50 seconds. The first 50 seconds stand from, this is 10, 20, 30, 40, 50. So the total distance traveled during that is BII. BII is simply ST is equal to what? S1 plus what? Plus S2. What's the meaning of that? That is the area of triangle O. Let's label this as okay, FGH. Let's put this point as H. As triangle HAG. The area of triangle HAG. That is half base times this height, plus the area of this trapezium. Do you get it? The area of this, for the area of trapezium, what? GFBA. Do you get it? This shape is a trapezoidal shape. Do you get it? So we are saying that our ST is equal to what? Half. Okay, let's do it one by one. Our S1 is what? Half base times height. In this case, S1 is what? 1 all over 2 times base. Your base is what? This is 10, 20, 30. Your base is 30 times what? 30 times what? Height. The height of this triangle is what? 240. So times what? 240. Of course, you know that 2 cancel here 1, 2 cancel here 15. So our 15 times 240. So we have 15 times 240. What do we have? Our answer is 3,600. So S1 is what? 3,600 meters. How do you know it is meters? Okay, this, let me prove to you. This is times 30 seconds. 30 seconds. 30 seconds times what? 240 meters. All over what? Seconds. This second will cancel this second. And then you are left with what? Meters. Do you get it? So the area of this particular guy is the distance covered within this range. Do you understand? So the trapezium, you have S2. Our S2 is half into A plus B times height. So in this case, our S2 is what? Half into what? Half into 240 plus what? 240 from here to here, 240 from here to here is what? 340 times what? Times the height. The height is what? The height is what? Let's check. The height is, this is 10, 20. The height is 20 times what? 20. So let's go to work. What do you have? You have 240 plus 340. 240 plus 340. Sorry, my calculator is trying to misbehave. I want to be sure of the result. We have 240 plus 340. That will give us 580. 580 times 20. Then that divide by 2. That will give us 5,800. We have 5,800 what? Meters. So the total distance traveled during the first 50 seconds, which is 10, 20, 30, 40, 50, is simply this plus this. And what do you have? What do you have? So if we do that, we have our total distance given as what? As 3,600 plus 5,800. What do you have? Our answer is 9,400. 3,600 plus 5,800 will give us what? Give us 9,400 meters. That is the total distance traveled during the first 50 seconds. 10, 20, 30, 40, 50. Now they will ask you to calculate the total distance traveled throughout the motion. How do you do that? Very simple. We have calculated from here to here. So just say the area of this shape plus the area of this shape, then add it to this result, and then you get the total distance traveled during the motion. So the examiners did not ask us to. They said we should calculate also. That is question BIV. Average speed during the same interval. Average speed simply means distance all over time. So the average speed, that is question BIV. Question 25 BIV. The average speed is given by this particular equation. And you know what that means? The distance divided by the particular time at that time. So we have our S is given as what? 9,400 divided by the time during this particular range. And that time is what? 50 seconds. So this divided by 50. This will go, so we have 9,940 divided by what? 5. Let's see what we have. So we have 9,400 divided by 50. Our answer is 188. So the speed is given as 188 meters per second. 188 meters per second. The speed is given as what? 188 meters a second. I believe we are done with solving that question. That question is an SSCE question, and this type of questions carries 15 solid marks. So in case the examiners want you to calculate the total distance covered during this motion, what you are supposed to do is this. The total distance traveled during this motion is simply ST equals to S1 plus S2 plus S3 plus S4. What's the meaning of this? The area of this, the area of this, plus the area of this, plus the area of this, plus the area of this. The area of this triangle plus the area of this trapezoid plus this area of this rectangle plus the area of this triangle. Do you get it? So in summary, the two of these guys have been calculated up here. So what do we need to do now? Just this and this. So we said our S3 is given as what? Area of rectangle A of rectangle BCEF. Do you get? So what do we do? The height is what? Length times breadth, right? So we have L times B. In this case, what do we have? We have 340 times what? Let's count. This is 10, 20, 30, 40, 50, 60, 70, 80. No, this is 10, 20, 30, 40, 50, 60. So this times 60. If you do that, this is what you are going to have. You have 340 times 60. Our result is this. We have 20400 meters. So the last section is the area of this triangle. That is S4. S4 is half base times height. Our base is, let's count. I told you my graph here is 1 cm to 10 units. So this is 10, 20. So I have 1 all over 2 times 20. My base is 20 times height. My height is what? My height is traceable to what? 340 times what? Times 340. If you do that, what do you have? We have 20 times 340. It will give you 6,800. So, meters. So the total distance traveled is this 9,400 plus this figure plus this figure. Let's do that quickly. So we have 6,800 plus 20400 plus 9400. The total distance traveled by this guy is given as 36,600 meters. The total distance traveled is, that is ST, is 36,600 meters. You can screenshot this quickly so that you can study it later. That is it. It was nice having you. See you some other time with physics, on Physics with Ben. God bless you. Bye-bye.